time. But we didn't even get through everything that we were supposed to get through yesterday. So, Ebenezer. Okay, number 14. Okay, so take a look at 14. It says the integral from negative 5 to 2 is equal to negative 17. 5 to 2 is negative 4. And then it asks you to find negative 5 to 5. There was a question very similar to this on your test, as some of you have come in and started correcting it. Okay, what is the smallest x value that I want? What's the biggest? 5. But 2 is between them. So remember, there's a property that says if I integrate from negative 5 to 2, and then I keep integrating from 2 to 5, that instead of keeping those separate, I can just go from negative 5 to 5. Do you remember that property? If I go negative 5 to 2, but then pick up at 2 and go to 5, I can just take the 2 out and integrate straight through. Okay, so negative 5 to 2, how big is it? Negative 17 plus. Now, careful here. I want 2 to 5, but I was given 5 to 2. Positive 4. And then this is the one that I want. Well, the negative 5 to 5 needs to be a negative 17, positive 4 here, which gives me negative 13. Okay, and they'll do stuff like that on the AP test. What I would do is start with this rule, then look for what you don't know, and then solve for that. Okay, the 4 is positive because they gave you 5 to 2, and that is backwards. So if they give you a backwards integral, you have to change the sign. Yes, Wilson?
We're only going to finish this the whole time.
We should be able to finish it today. Every other class has had like 10 minutes at least left over.
Oh,
okay, we're turning the page. Next one. Okay, what is the integral of lowercase f of x from a to b? There's a rule that says what this is. Okay, it's the fundamental theorem of calculus. Okay, here's what the fundamental theorem of calculus is in case you forgot. Okay, fundamental theorem says that if I want to take the integral of little f, I get the antiderivative of f, which is what? Antiderivative of little f is big F of x. And then what do I do with big F of x? I plug in b, I plug in a, and then what do I do with those two when I'm done? Subtract. So the integral a to b should be capital F of b minus capital F of a. Which answer says that? D. Okay, that's literally the definition of how to do an antiderivative. You do the antiderivative of little f, you get capital F. You plug in the top number, then the bottom number, then you subtract. Yes?
where in the question do you get fundamental?
So they're not telling you what's the fundamental theorem of calculus, but they're asking you, what is this integral equal to? This is the notes from yesterday, number 15. So you need to turn the page. After, yep, you got it. Okay.
Wait, so when will it ever be prime?
Okay, real quick, the other version of this, since Wilson asked, if it was integral a to b of f prime of x, what would the antiderivative of f prime be? Regular f of b, and then regular f of a.
Hey, can you give me 5 seconds?
Okay? So, if you start with regular f, the antiderivative becomes capital F, but if you start with f prime, the antiderivative would be regular f, because you're undoing the derivative. Yep. Good. Okay, now, number 15 is a definition, okay, but the real AP question was number 16. So, look at number 16 off the AP test. Okay, it says, find the integral from 1 to 3 of f of 2x dx. Well, this is no longer a regular rule. Now it's a u sub of that rule. So what would I choose as my u? 2x from the middle. If u is 2x, what's du? 2dx, which means that dx is du over 2. Everybody good to there so far? Okay, I come back over here. This is now the integral of f of u du over 2. And then where can the 2 move? Out to the front as a half. So I have the integral of f of u du with a half in the front. Now, before I go to do the antiderivative, I got to change my endpoints. Remember, we talked about that. So if this is a 1 and a 3, and I plug them in here, what's 2 times 3 on top now? 6. And then what's 2 times 1 on bottom now? 2. What's the antiderivative of lowercase f? Antiderivative. Capital F. And then what do I do with my endpoints? I'll plug in 6, I'll plug in 2, then I'll subtract. So take a look at your answers. If I plug in capital F of 6, I have a half f of 6. If I plug in capital F of 2, I have a half f of 2. And if I subtract those, which answer is going to be right? Which one? E. Because remember, I need the halves here, and then I can't use the original endpoints. I have to change them using the 2x for my u. Make sense? Okay. Okay, next one. Take a look at number 17. Okay, so number 17 is a little bit trickier. We're going to practice this a lot more after we finish u substitution. But look at each of your integrals. Do you see how several of them have the integral from 2 to 4? So I'm going to start there, and I know this is kind of a stretch with what we've done so far, but if I integrate 2 to 4, f of t dt, what would I get? We've done it now twice. Antiderivative of little f is what? Capital F of what first? 4 minus capital F of 2, right? That's the fundamental theorem of calculus. One of these numbers, they're telling me what it equals. What is f of negative 2? Negative 7. So what that means is that the integral from 2 to 4 of f of t dt is capital F of 4 minus negative 7. We good with that? Okay, so we're just kind of trying it out. So I know the integral of little f is capital F of 4 minus capital F of 2. They told me capital F of 2 is negative 7, which means that this is really a plus. Okay, what are they asking me to solve for in the equation? I want to know what f of 4 equals. Well, if I want f of 4 by itself and there is a plus 7 on its side, how do I move this plus 7 across so that f of 4 is by itself? I'll minus it across. So I'll have my integral 2 to 4 of f of t dt, and then I'll have a minus 7 in front of that. Same as answer A. Now, what is wrong with D? Because D is really close. Yeah, they added the negative 7 to the integral. That should not be inside, it should be outside. So A would be correct. That negative 7 would need to be outside the integral. Make sense? Okay, good. All right, turn the page. We have 3 more left, and then 1 FRQ, and then we're done. Good to turn the page? All right, next one. I want you to give it a shot. Okay, I'll give you a couple minutes, but before I do that, let's just get on the same game plan of what we need to do. So, it says, for any constant k, we're given that the integral is equal to 18, then it says to find the value of k. All right, so think about, what would I normally do if I knew that the integral from 0 to k was what I was looking for? What would I do first? Take the antiderivative, and if I have endpoints, what would I put it in? I would put it in brackets, right? So you're going to take this middle part here. You're going to find the antiderivative. Then what are you going to plug in? F of k, then f of 0. Once you find these two things, what are you going to do with them? Subtract. So you'll do one minus the other. And what is the answer supposed to be equal to? 18. And then what are you going to do after you set it equal to 18? You're going to find the value of k. So, take a second, give it a shot. I will do it for you, but I think probably several of y'all can figure it out without help. So do the antiderivative of this. Then you're going to plug in k and 0, subtract, set it equal to 18, see if you can find k. You don't need u sub. Why don't I need u sub? Because nothing's like plugged into anything else, right? So like for example on the 2kx, what's the antiderivative of that? X becomes an x squared. And then when I divide by 2 or put a 1/2 on a 2k, what happens? Just a 1k. Does that make sense? So I'd increase the x to be an x squared. Then when I divide by 2 on 2k, now it's just a k. Okay, next one was an x squared. Antiderivative of that, what do you get? 1/3 x cubed. And then next I want to plug in k. What happens when I do k squared times another k? K cubed. So I get k cubed on top minus, and then I have 1/3 of k cubed again. On bottom, I'm plugging in a 0. What's 0 times k? What about 0 times 1/3? So this bottom one just comes out to be 0. So I have k cubed minus 1/3 k cubed, and then I'm taking away 0. Well, then the 0 nobody really cares about, right? Not necessary. What do you do next? Okay, you could multiply by 3 to get rid of the fraction. That's fine. So if I times everything through by 3, then what is my k cubed now? Now it's a 3k cubed. And then what's 3 times 1/3 here? 1k cubed. 0, nobody cares about, it goes away. And then 18 times 3 would be 54. What is 3k cubed minus 1k cubed? 2k cubed. What do I do next? Divide by 2. 54 divided by 2 is 27. And then if k cubed is 27, is it plus or minus 3? Plus only, because what kind of root is it? A cubic, you don't end up with a plus or minus. Well, that's very sweet. What an inspirational ringtone. It's very nice.
I didn't know you like classical music.
Thank you, Q. Thank you. Okay. Okay, 2 more left. 2 more multiple choice. Okay, ready? Shh, shh, shh. Okay, one of them is average. Shh, shh, shh. Okay, one of them is average value. One of them is average rate of change, or AROC. So, look at your last 2 questions. Mark which one you think is which. Okay, don't say it out loud. Just think about it in your mind. Okay, one of them is average value. One of them is average rate of change. In your mind, decide which one you think is which. They both say average, but now there are 2 averages. Okay.
take the joke with it. I'm chilling. I'm tripping.
I don't know. You got a concussion when you got beat up. Okay, which one's which? Which one is this?
Average value.
Yay. Okay, listen. I'll explain to you why one more time. Okay, it is average value because for average value, your units stay the same. Okay. So, if it's velocity and this is velocity, my units would not have changed. Velocity is meters per second. Average velocity should still be meters per second, or feet per minute, or miles per hour, or whatever. Okay, now come down to this one. This is velocity, but what's this? Acceleration. And acceleration is the derivative or the slope.
Oh my god, and you didn't say anything.
Okay, so average rate of change is the slope of the function. Okay, so if this is velocity and I want acceleration, I should be doing AROC. Versus if I want the average of the same thing, I should be doing average value. Now, when you do average value, what is the equation that you would do? 1 over, okay, 1 over b minus a, integral a to b, f of x dx. Okay, versus for average rate of change, what would you do? F of, okay, and you have to know the difference. Okay, average value, you're measuring the average of what your equation is. Average acceleration, you're measuring the average slope of that graph, okay? Now, we are going to work out number 19. Okay, what would my equation be when I start plugging in the numbers for this equation? So it would be 1 over 2 minus negative 1 integral negative 1 to 2 of 3t cubed minus t squared dt. Okay, this you should be able to do without a calculator. So 2 minus negative 1 is really what? 2 plus 1, which is 3. So this is a third. What is the antiderivative of 3t cubed minus t squared? One term at a time. That's the derivative. We're doing the antiderivative. So t to the 4, and then I divide by 4, so it's a 3/4. Then what's the antiderivative of t squared? 1/3 t cubed, yeah? Okay, then what are we plugging in on top? On top we're plugging in a 2. On bottom we're plugging in a negative 1. Now, the 1/3 that's out here for right now, I'm just going to ignore it, even though it's there. Okay, because I don't want to have to distribute a fraction into what I'm plugging into. Okay, so let's do 2 first. What's 2 to the 4th? What is 16 divided by 4? Go smaller first. 4. And then what's 4 times the 3 on top? 12. Second term, 2 cubed is 8. A third of 8 doesn't simplify, so I'll just leave it as 8/3. So on top, I got 12 minus 8/3. On bottom, I'm plugging in a negative 1. Negative 1 to the 4th turns positive. So now that's just a 3/4. And then negative 1 to the 3rd stays negative until I times it by the minus on the 3rd. Then what happens? Plus a 3rd. And then what do I do with these two things? You subtract them, and then what's in the very front that we don't want to forget about? The 1/3. So I'm going to subtract first. I'll put the 3rd back at like the very end. So if I do 12 minus 8/3 minus 3/4 plus a 3rd, then let's distribute this negative in. So really I have 12. What is negative 8/3 minus 1 more third. 9/3. What is negative 8/3 minus 1 more third if it's negative 9/3? What's that the same as? 3. 9/3 is just a 3. And then I have a minus 3/4 still. So I'm basically combining both of the thirds because they kind of work themselves out to a whole number, which is easier. Okay, then 12 minus 3 is 9, and I want to know what 9 minus 3/4 is. So I will times 9 by 4/4. That gives me 36/4 minus 3/4. What's 36/4 minus 3/4? 33/4. And then what was in the very front that we can't forget about? A 1/3. And how can 33/3 reduce?
33 times 3.
Not times, divide.
Divide by 4.
So it'd be 11/4. Okay? So, not impossible, but that one on the AP test would have taken you probably a little bit longer than most of them. Okay, number 20, we're not going to bother to do that one. We're going to go to the FRQ. Okay, but you should be able to do it. You're just plugging in 2 and -1 and then subtracting. Correct. Number 20, the answer comes out to be C. Do you want to just do it? I want to take it. You would just do V of 2 minus V of -1 over 2 minus -1. If you plug in a 2 first, 2 cubed is 8. 8 times 3 is 24. Minus 2 squared would be a 4. So this comes out to be a 20 minus. Okay, next I'll plug in -1. 3 times -1 cubed stays a -3. But then I have to minus -1 squared. Does this stay negative or turn positive? Why does it stay negative? The -1 squared turns positive, but then I have a third negative out here. That's a -3 minus 1 more. Oh, okay. So just be careful on that. If I square the -1, its negative goes away, well then I'm truly subtracting that because I can't cross out the negative on the subtraction. 20 minus -4 is 8. 2 minus -1 is 3. Oh wait, hold on. That's a plus. So that becomes 24/3, which is 8. Make sense? Okay. Next one. This is the last page. We made it. Okay, let's see if we can do it. Did y'all take the AP mock today? How'd it go? For English, if you're in AP English. Whose birthday is it? Is it really?
Happy birthday to you. Happy birthday,
Dear Mike, happy birthday to you. Okay. Is it really your birthday? Oh, you guys. I just wanted to wake this poor little girl up. Okay, hard aim. Okay, so it says, Karen, she's riding her bike along the road from home to school. Ebenezer. Okay, then it says she arrives at school at 12 minutes. During the interval, her velocity in miles per minute is modeled by the piecewise function. Okay, guys. Okay, so velocity is measured in what units? Miles per minute. Okay, then how will I find her acceleration if I have a graph of her velocity? The slope, or the derivative, where do I want the derivative at? 7.5, which is this little chunk of graph. This is an AP question, yes, where we've been reviewing. So, what is the slope of that line segment? Don't say -1, that's wrong. -0.1. Okay, we're going to find the rise over run because it's the slope. So my rise would be -0.1. My run would be 1, which is -0.1. Okay, if you put -1, that would have been wrong, so just careful with your axis. Okay, then from there, reread part A. What have I not done that I'm going to lose a point for?
Units.
Okay, units of measure. If this is miles per minute, what is the slope or the derivative of that? Miles per minute squared. So look, if I went from 0.3 to 0.2, how much did I go down? 0.1. How much did I go over? 1. Now the other thing too to tell you is, remember, on a line you should always count from the pretty points. So like I don't want to try to count from 7.5. That's in the middle of the line. Okay? Yes. Okay, part B. What is the meaning of the integral of the absolute value of velocity? Distance traveled. Very good. So this represents the total distance traveled by who? Okay, by Karen. What is it measured in? Distance isn't measured in miles per minute. Okay, in miles. Perfect. Okay, over 0 to 12 minutes. Now, why can I not say displacement? Because displacement can be positive or negative. If they put these bars here, you have to say distance traveled. Okay? Then it says to find the value. How do you find the value if you have a graph? Area. Now, someone in the other class did this, and I thought it was kind of smart. I think it's annoying, but maybe you'll like it. Okay, if you count the whole number boxes, then you don't have to break it up into as many shapes. So watch, I'm counting whole boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Then I only have a couple of shapes left over that I have to mess with. If you like that, do it. Now, here's the problem if you do that. Is this area 11? It's 11.1s. So what is 11.1s going to add up to? 1.1. So all of my pink boxes are 1.1. But then I still have these two little matchy-matchy triangles. Okay, this little triangle here. This little triangle here. And this little triangle here. Now, let's talk about either way. Are you still going to have to find the triangles? Yes. Okay, but if that makes it easier for you to think about, do it. Okay, so let's find this triangle first. 1/2 base times height. What is the base of the triangle? 2. What is the height of the triangle? 0.2. 2 times 0.2 is 0.4. Half of that is back to 0.2. Now, if this one's 0.2, how big is this one? Do they cancel out? Okay, so don't get tricked. Okay, if we did not have those bars, yes, they would cancel out, but they do not cancel out. Okay, let's do this one at the end next. 1/2. My base is a 1, my height is a 0.2. What is half of 0.2? It's not negative because of the absolute value bars. Remember down here they put bars. I wouldn't put the negative because I wouldn't want to forget to count it as positive, but it's up to you. Okay? Then we still have 2 little triangles left. This one up here would be 1/2. Base is 1, height is 0.1. And I would think about 0.1 as 0.10, so I can cut it in half. What's half of 0.10? 0.05. And then this guy here would be 1/2, 1 times 0.3. But I would think about 0.3 as 0.30, so I can cut it in half. What's half of 0.30? 15. And then, if I want to be super lazy, when I do my part B, I'm just going to list it out added. I'm not even really going to add it. You can if you want to, but I'm not going to. Yes?
Okay, so if you didn't do like that shading thing, circle thing, would you do like erasing those?
Yeah, the way that I did it when I worked the problem is I would have done this as one big trapezoid, this as one little trapezoid, triangle, triangle.
Oh,
But as long as you count everything, it doesn't matter how you break it up.
So why'd you show us that way?
Because the other class was like, that's so much easier. And I was like, maybe they'll like it, you know? Okay, so I have 0.2 plus 0.2. How much is that? Okay, 0.4. Why did they not cross out? Because of the absolute value. Okay, then what is 0.15 and 0.05 if I put those pieces together? Okay, 0.2 or 0.20, which is the same. Okay, plus, then I had my big pink chunk, that was 1.1. And then I have my last little chunk here, which is another 0.1. Okay, and I guess since we already added it up that much, we might as well finish it. 0.4 plus 0.6 is... Oh wait, 0.4 plus 0.2 is 0.6, then 0.7, so 1.8. Okay? Okay. Part C says, shortly after Karen left home, Karen realizes she left her calculus homework and she returns to get it. At what time did she turn around to go home? 24 is not even on the chart. At 2, how do I know 2? She was going forward, and then she switched to a negative velocity and was going backwards. So when did she change direction? At 2. So you would say at time t equals 2 because Karen's velocity changed positive to negative. I know. This Karen really wants to talk to the manager. She has a C. You know?
What does it mean, okay, Karen?
Oh, you tell her. Okay, part D. Last part. We can do it. Okay? Larry also rides his bicycle along a straight line in 12 minutes. Larry, his velocity is modeled by, and then instead of picking V of t, they already used V of t up here, so they decided to use W of t. But remember, this is Larry's velocity. Okay, they just didn't want to create a second V equation. Then it says, who lives closer, Karen or Larry? Let's find how far Larry lives. How will I know how far away Larry lives if I know his velocity? Yes, which means I need to do an integral. Yes? Okay, so, velocity tells me, if I integrate it, how far I traveled. So I'm going to integrate Larry's velocity from 0 to 12 minutes. Okay, now, just because they both traveled for 12 minutes, it doesn't mean they went the same distance. One of them might have been going faster. So, we're going to integrate pi over 15 times the sine of pi over 12t dt. And then, as someone said, that is going to require u substitution. So when I integrate Larry, I'll know how far he traveled, and then I can compare to see who went the farthest, okay? So, what will I choose as my u? Pi over 12t. That's like pi over 12x. Then what is the derivative of that? So it'd be pi over 12 dt, right? Because I take the derivative of any number with an x is just a number. Okay, and then to solve for dt, I have to flip this and multiply on the other side. So dt is du multiplied by 12 over pi. And you could put it in the other order. It doesn't matter. I kind of wrote that in a weird order, but it's the same. Okay, so redo your integral. You have a pi over 15 in the front, sine of u, and then your dt is now a 12 over pi du. Again, order doesn't matter, okay, if you put the u or whatever first or second. What happens to the pi's? 12 over 15 is going to come to the front. What is 12 over 15 when I reduce it? 4/5. So I have the integral of 4/5 sine u du. What is the antiderivative of sine u? So it's going to be negative 4/5 cosine u. Why do I not put a plus c? Because I have endpoints. What do I need to do with the endpoints before I plug them in? Change them right here. So if I plug in a 12, I have pi over 12 times 12. What happens? Now it's just a pi. And then when I plug in 0, I have pi over 12 times 0, which is still 0. So my bottom endpoint doesn't change, but my top one does. Then I'm plugging those numbers in. Now, what is cosine of pi when I plug it in? And negative 1 times negative 4/5 becomes positive 4/5. Versus down here, I plug in 0. Cosine 0 is 1. Multiplied by negative 4/5 stays negative. And then how do I find Larry's total distance? Top minus bottom. Am I going to get 0? No. He's 4/5 minus negative 4/5, which means that he went 8/5. Okay, now, let's say that you are really bad at comparing decimals and fractions. Okay, very good. All you have to do is a little long division. Okay, so what's 8 divided by 5? Okay, 0.0. We'll add a 0 on the end. How many times can 5 go into 8? Carry down the 5 and subtract. 8 minus 5 is 3. Carry down the 0. How many times can 5 go into 0.30? 0.6. Okay, then that would be a 3.0. Subtract, you get 0. So Larry went 1.6 miles. Now, question. Carrie, or whatever her name is, Karen, okay, she went 1.8 miles. Does she live farther away? What did goofy old Karen forget at home? Her book. So this 0.2 and that 0.2, those don't count. So how much do I need to minus off her total distance? 0.4. So she went 0.8, but 0.4 of that was her own stupid fault. So she lives how far away from home? 1.4. He lives how far away? 1.6. Then who lives closer? Karen. Get it? Okay, we love Karen. Karen lives 1.4 away, which is closer. Yup. Okay, now, real quick. Okay, before you put all your stuff away, I want to show you the multiple choice, whatever, thing for this off the AP test. Never mind, I lost it. Oh, wait, I found it. Here it is. Okay, so look, here's how the points would have broken down. Okay, as we get closer to the AP test, we'll look at this more. So in part A, you would have gotten 2 points. Every FRQ is out of 9. If you're not taking the AP test, just don't listen, but be quiet. Okay, so your answer, negative 0.1, was worth 1 point. Your units was worth a second point. So even if this was wrong, if you put miles per minute squared, you would have gotten half of those points. Okay, in part B, you got 1 point for the meaning, but you had to say total distance in miles over 0 to 12 minutes. If you didn't say all 3, you don't get that point. Then the value of the integral, you could have left it chunked up, or you could have added it all together, doesn't matter. Okay, in your part C, turned around at 2, that's one answer. Your reason was the second point. Okay, so you should see you get partial credit along the way. Then the last part, part C, you got 1 point just for setting up the integral. Even if you did it wrong, if you set it up right, you would have gotten 1 point. Work it out correctly, second point. Then your third point would be to compare. So even if you forgot that she really only went 0.4 and answered wrong, you still would have gotten 8 out of 9 on the question. Okay? Yes? Oh, no, they're stressing me out.